All right, let's look at igneous rocks here. Now remember, igneous rocks are formed from the solidification of molten magma. They can happen in two different ways. So let's have a look here. So first of all, make sure you write this down, that igneous rocks, when hot magma cools, forming crystals, and that there's two types of igneous rocks depending upon how they cool. There are intrusive rocks. So intrusive means they're cooling down underneath the Earth's surface. And so you can see here with my diagram, I'm showing you that rocks down here and along the line here of where this little lava section is, which we'll learn about the names later when we do volcanoes, right? But there's similarities in these two rocks. If you zoom in, what do we see? Well, we see that these two rocks have large crystals. You can see the crystals with your eyes, right? So that means that these types of rocks, called intrusive rocks, form large crystals, and we're going to look into that in more detail. Then you have extrusive rocks. These extrusive rocks form on the outside. So you can see I've got here the volcanic bombs up here. We've got the lava flow, and we've got those that are outside that form in oceans. And you can see with all three of these, they've got very, very small crystals. So we've got very microscopic crystals with our obsidian there, with our basalt, tiny crystals, we can't see them. And then pumice, we've got tiny crystals, but you do see all these holes. And we'll look at pumice in more detail later, but they're just holes from gas. Okay, so there's two main classes of igneous rocks, intrusive and extrusive, depending upon where they're formed. Now, let's have a look at some more detail of this. So in igneous rocks, when we have fast cooling magma, produces dark coloured fine-grained basaltic rock. And so here is basalt here. We can see that with our basalt, it's got very small dark crystals. It has low silicon. Now silicon is an element on the periodic table, but when we talk about silica, it's a mineral that makes up rocks, and so they have low silica content, okay, and they're rich in iron and magnesium. And we can see some what are called pillow lava here. This is formed underneath the water in Hawaii, and then we have some lava here that is on the surface of a volcano, and so this is basalt here, okay, and basalt is a very dense rock, and it forms a large proportion of the rock and ocean crust. Okay, so that's one form of igneous rock, basalt, small crystals, so that means it is an extrusive rock. All right, let's have a look at another extrusive rock with very small microscopic and maybe not even crystals in it, which we call amorphous, and we'll look at that later. But fast cooling magma that goes in the water can also form obsidian. Now, obsidian here, as you can see, it's a very lustrous rock. That means light reflects off the surface, right? So it's very shiny, which we call lustrous. It's mostly black or brown in color, and as you can see, when we hit it, it sort of fractures along planes, and we get these big flakes coming off, which means we can actually shape the rock. And here you can see some obsidian used as arrowheads or spearheads, and we can also use them as knives to help cut meat and peel away skin, for example, when they're skinning animals. So that is some uses in history. So it is an extrusive igneous rock, cooling down very quickly, so quickly it makes like a glass-like finish. Here we have pumice, which is another extrusive rock. And here we have a volcanic eruption. I remember this one quite well. This one was in 1991, so back then I was still at uni. But it is a massive volcano, Mount Pinatubo, and it released ash into the atmosphere that impacted massive regions of the Earth because it took a long time for this ash to fall back down. But here we have pumice. Now, pumice is a light-coloured porous rock. As you can see, it's got little holes in it, and those holes are due to gas trapped in the lava as it's being released from the top here, and so we can see very, very light rock, okay, and it floats on water. What about some intrusive rocks? Well, intrusive rocks, remember, are formed inside the crust, which means they cool down slowly. When they cool down slowly, they got more chance, more time for the atoms to rearrange and form nice, beautiful crystals. And so we can see here some granite, and we've got lots of different things going on in granite. We've got very large crystals. We can see that those crystals are different colors. So we've got our different minerals here. So we can see the white gray, that's a feldspar mineral. Okay, maybe even pink and red. And then we have some quartz and some mica. And so all of this is easily observed with our eye, and so therefore we say we have large crystals. And that happens when it's slow cooling. And we can see a marble bench top here. Okay, and so when we get from granite, we put that under high pressure and temperature, and it actually turns into marble. So that's it for this little video introductory into igneous rocks. We've talked about quite a few things here. We've talked about the main concepts here is that you have igneous rocks forming from molten magma cooling down. And when it cools down in two different ways. We've got under the earth, which is called intrusive, cools down slowly to make large crystals. And then we have cools down fast for extrusive rocks, where we've got very small crystals. And we had a look at some examples of some main types of intrusive and extrusive rocks. So that's it for this video. Make sure you got them down, you got your flow diagrams down, any detail in terms of your definitions you've got written down as well, and you're revising actively. So I'll see you in the next video.